Dzień dobry, Wrocław. Thank you for having me. I'm thrilled to be here. Let me just get a picture of all of us to post on Twitter. Perfect. So I just want to say you're amazing people and you're freaking smart. I mean, Pavel's presentation yesterday and Nick's and Yaroslav, that was amazing. That you caught like the essence of view components and Hotwire. And thank you for making the difference of Hotwire and React, because it's important to know that there are many tools in our toolkit and we should use the proper ones. So we should not hate technologies. Maybe Clojure, but no, we shouldn't hate. No, it's all good. Elixir, yeah, yeah. Perfect. So I'm going to talk to you today about how to package a Rails engine from generation to automation. It's a real trivial subject from your nice talks. So I'm Adrian. I'm the author of Avo. Avo is an application building framework built on top of Ruby on Rails. So it helps developers build tools 10 times faster. I've been a freelancer in digital agencies, in corporations, in a Silicon Valley startup. I've been everywhere, but now I'm trying to be an entrepreneur. You can find me, Adrian the Dev, everywhere, adrianthedev.com. And if you want to check out Avo, go to avo.cool. So what is a Rails engine? So a Rails engine is basically a miniature application, a miniature Rails application inside your host application. So a mini-me. It holds its own routes, its own models, its own controllers, views, and so on. So when would we use an engine? So let's take, for example, we're building like a marketplace app. We'll always have like buyers and we'll always have sellers. And they'll probably have like different admin panels, different back offices, and different functionality. So how would we go and build that if we weren't using engines? So we can go to controllers and create a new directory, buyers, and add all our controllers, and another sellers, and so on. Then we'd go to models and add our directory there. Or we can generate new engines, buyers and sellers. And those engines would be like separate apps in which to keep all your logic. Perfect. So this is perfect when you are building an engine for yourself, for your company, for your own app. But maybe you're building something that you want to share with the world, something like maybe an admin panel framework. I don't know. Cool. So let's start work. So we'll generate an engine. So we'll just write like Rails plugin new admin. And you want to add the mountable option, so you get all of those goodies like the controllers, the models, the directories, everything auto-loaded for you. You'll also get a dummy app inside your test directory. So this dummy app is another Rails application on which you can test your code. You can test like automatic code, or you can do manual tests and run your engine inside that app. So what are we going to build? So we're going to build this admin panel framework, which is actually, it will go and find all our models. It will display them on the sidebar with a link to an index page where we'll see all of our records. So all the users, posts, and comments, and so on. Test your engine. Test all your code. That's very good advice. So this is a small test that just loads a page and makes sure everything passes. Cool. So how are we distributing this thing? How are we distributing this engine? The easiest way is through Ruby gems. And how do we do that? We do that using the gem utility. And we can, the gem utility is using this thing called a gem spec file. So every engine that you generate and any gem that you generate will have this, this information. I'll just go through it really quick. So think about the gem spec as the package JSON to your package. Like what package JSON is to NPM, the gem spec is to your engine, to your package. So in the first section, you have like some information about the package, like the name, the author, the version, the description, and so on. Next, there's some metadata that you can add to your gem spec. These are some links from Avo. These links are used by Ruby gems and other websites that are scraping this gem to show the page nicely, and it will show like what's the home page and the bug tracker, the issue, and everything else. The files option. This is very important because when you package it up, and we'll talk about this, You don't want to add everything. Maybe you have like dot files inside your repo, you have Node.js node modules directory, and you definitely don't want to pack that. So here, this is the place where you specify what files you want added to your gem. Last but not least, the dependencies. So let's say you're running like Pundit. You're using Pundit in your runtime. So you can go about it in two ways. You can build your gem and not add a dependency, and then you can write it in your documentation like, hey, you must install Pundit for this to work. And nobody reads it, nobody does it, and it will be broken, and you'll get like bad reviews online. Or you can do this. You can specify. You can say spec add dependency Pundit, and that will, when the user runs bundle install inside their host app, the parent app, bundler will go read this configuration and take that into account. So it will add Pundit at the runtime. Of course, yeah. That's another thing you can do. You can add dev dependencies, or you'll also get a gem spec inside your engine. So you can use that gem spec. It's a regular gem file. Sorry, it's a regular gem file where you can add things for that dummy app for your development dependency. So you can do that, or you can do this. Thank you. Cool. So let's build a thing. Bundle exec Rails build. And it will take all of those files, it will take that option that I told you about, and put everything together inside one gem file. What I like to do is build in isolation. So as I said, you might have like dot files. You might have different environment variables on your local machine. So you'll have like Rails environment and Node environment set to development instead of production. So maybe assets won't be compiled properly, or maybe when you run the build command, you have a different version of your assets. So what I like to do is build an isolation. So I'm using Docker for this. I'm just going to go very fast through it. So I'm starting from a Ruby image. I'm installing something for Linux. I'm caching Nokogiri because it takes a long time, and this layer will be cached by Docker, so it will only run the first time. I'm installing bundler. I'm setting those environment variables so everything compiles down properly. I'm setting the work there, copying everything over, running the bundle install, so installing everything on Docker, and then just running the build command that I just showed you. Now, your Docker image has that gem file that you generated in isolation. So all the assets should be like they are, like the environment variables and so on. Perfect. Of course, that gem file sits inside the Docker image, so we're going to use a helper script to pick that up. So we're taking the version of the gem, we're building the image, we're taking that image ID. What I like to do is to delete the latest package, because usually when I use that building and isolation technique, I usually use it to send up like bug fixes or try out features before I release to main, and I release a stable release. And sometimes I do that and I build multiple packages. So if something happens to the Docker image, I know, and it doesn't output the good package, the good gem, then I might send the wrong gem over. So I make sure I delete this one so I have the brand new one. So another command like docker copy, and I'll take things from Docker and to my machine. Cool, so what's left? So publish the thing. So to publish, we're going to use the gem utility, and we are going to use the gem push command. Perfect. So there it is. You published your work. Everybody can see it. So you've done a good job. You're helping a lot of people. But what happens when you publish it and somebody writes to you on GitHub, hey, you have a bug? Or maybe you want to add a new feature. So we want to release again, and we are using versioning for that. So whenever we generate a new engine or a new package, we get this version RB file, right? And it will start at 0.1.0, and you can go in, increment that 0.2.0, run bundle install, so that is added to your gem file lock file, and then you republish it. Or you can use the bump gem. So this will increment the version. You can specify like, okay, bump it like a pre-release, a minor, a major, or a patch version, and it will play with the digits and add whatever version you told it to. This will commit the code. It will even cut out a tag for you and push it to GitHub. Cool. And now, like whenever you have this package, you have this thing that helps everybody. You gotta make sure whenever you publish something new that you tell them what you did, because there's nothing wrong like when you update a package and something breaks and you never know what happened and you have to like check the code, to check the source code and everything. So you have to publish like release notes. There are a few ways of doing that. You can use like a changelog markdown file inside your repo, and every time you push an update, you just write it there, like I fixed this, I added this, and you commit that to your repo. You can use Confluence if you're in that type of thing. You can use like your own documentation pages, or we use GitHub releases. GitHub has this notion of a release which is attached to a Git tag whenever you push a Git tag, and you can add like titles and bodies and other things on it. So what is our update workflow? So we push the initial version of the gem, and now you want to add like a bug fix or a feature. So first, you check out a new branch, you add your changes and commit. You push to GitHub and open a PR. You merge the PR. You pull the main branch back on local. You bump the version number. Then you build the gem, publish the Ruby gems, and make sure the changelog is properly updated. So yeah, it could be tiresome. Cool, but we can automate a few things. So that's what I want to talk to you about today. So we're going to use GitHub Actions for that. So GitHub Actions, like most CI systems, you tell it to run certain tasks. Those tasks can be like bash commands, like some pre-made actions. You give it some configuration from environment variables and secrets, and you tell it when to run it on events. Maybe when you merge a PR, when you open a PR, you can set up a cron job at a certain time, or you can click a button and give it some arguments, and those arguments will be available for you inside that CI system. The nice thing about GitHub Actions is that it has a marketplace. And that marketplace has a lot of pre-made actions that will definitely help you out. These actions can do things like check out the code. It can label PRs. They can set up like layering, caching layers, and trigger other automations and so on. Cool. So let's automate the testing. We give it a name. Then I hope everybody can see it. We tell it when to run. So it will run every time we open a pull request towards main, or whenever we are pushing to main. So we want to test our code every time. Then we have some jobs, and we are going to test it with the matrix strategy. That matrix strategy is that time when you lean on your back to dodge bullets. No, I'm kidding. It's testing against multiple Ruby and Rails versions. So now we're testing against Rails 6 and 7, making sure everything works, and Ruby 3.0. Next up, we have the environment variables. So the environment variables can be, actually, no. Yeah, perfect. The environment variables can be simple things like Rails environment. You can even set up, where is it? You can even define like variables inside those environment variables. So this will set to true, like the coverage will be set to true only if the Rails version is 7 and the Ruby version is 3. So you can even play around with that. So it runs on Ubuntu. Next, I'm setting up Postgres. You can set up Postgres, Redis, and some more services. Next, I'm checking out the code. So this is one of those pre-made actions. So I don't have to do git checkout and give it like the commit or the PR. It will just know. Next, what am I doing? Oh, this is the checkout, sorry. Next, I am setting up Ruby, and now you'll see that, oh, perfect, thank you. So now you'll see that the Ruby version that I want to use, this is another pre-made action. So the Ruby version is actually read by that matrix. So one time, it'll have like 4 jobs, and 2 of them will have Ruby 3.03, and 1 will be 3.1, whatever we defined in that matrix. Then we install Postgres client. We do a bundle install and create the database and migrate it. Then we run our tests, and like if the tests fail, like our spec is going to generate these images of the failed tests, and also so the HTML. So if the tests pass on your machine and they don't pass on the CI, you can figure out from the logs what's happening. You can create, RSpec will create these files for you. But this action called, upload artifact, this will take those files, which I defined here, like this directory, spec dummy, temporary screenshots, and create an archive for me. So that archive will be available on this job, so I can download those files and inspect what happened on my CI system. Next, and this step will run only if the outcome of the testing job is failure. So only if it fails. If it doesn't fail, this will be skipped. Cool, and then you can generate coverage. There's another code cov action. Just give it the token, and it will generate the coverage, and we'll send it to the code cov. Cool. Next, automating linting and code analysis. So we're going to use review dog, and we are going to do this on each pull request. So whenever somebody creates a PR, this task will run. And this has like 2 jobs. One of them is standard RB. So again, another pre-made action, and one is ESLint. But the nice thing about this, like GitHub and these actions, is that not only they'll fail, but they will highlight on your PR what happened. So you'll see at the exact line, you'll see a comment with the exact like warning with what happened. And even more, there are actions that can offer suggestions. So this is what you have to do to fix it. So you just click commit suggestion, and that's all. You don't have to like do it on your machine and push and so on. So that's very nice. Cool. So what happens is, like, even if you have like a small repo or a big repo, you might have like it can get very gnarly very soon. So labeling the PRs, that could help a lot. So we are using a popular popular strategy using like features, chores, fixes, and refactors. You can add style, test, docs, and others, but these are like maybe the most popular for us. And what happens is this will run every time somebody opens a pull request, and using this action, PR labeler, and this will read the name of the branch. So we create the branches as feature / and the name of the feature, or fix / what we fixed. And this action will read that and automatically label them. You can use multiple strategies, read from the body of the PR or from the first commit message or something else. So you can use multiple strategies. Automating the release notes. So this is cool. Again, we are going to run this every time we merge something to main. And we are going to use, again, an action. So release drafter is an excellent action. So what this does is get the commit hash from your latest release and do a diff to whatever you merge now and pick up all of those PRs, and it's going to create the release notes automatically. So you'll get them properly, nicely categorized, like features, bug fixes, maintenance. You can customize these, and they'll have like the name of the commit, the author, and the PR, which GitHub makes a link. So that's very nice. You'll also get somewhere in the footer, you'll get all of those contributors that help you out. Cool. So we're getting close to the grand finale, automating and cutting a release. So I told you that we're using the bump gem, and it will cut a tag for us and push it to GitHub. So this action runs whenever a tag with v.star gets uploaded. And it's starting to run the tasks that I have told you until now. So it will check out the code. It will set up Ruby. It will do a bundle install. It will build the gem. Next, I'm fetching the gem version. So I'm fetching that off of the name. I can see it now. Off of the name of the the tag, off of the name of the tag. And then I'm fetching the release notes. So the release notes that we previously built using automation. I'm using a JavaScript file here, so this could be a good place to set up a pre-made action. Cool. Next, we are creating a release. So I told you about the notion of a release that is attached to a tag inside GitHub. So we have to give it We have to give it a tag name to which to attach it to. We have to give it the release name and the body. So all of those release nodes that we automatically generated and fetched in the previous step, now they are going to be added to this new release. And next, we are uploading the release assets. So the gem file that we just built, we want to upload it to this release so everybody can have it if they want to just download it and don't want to use it off of Ruby gems. And now we are pushing to Ruby gems. So we are adding credentials and just doing like a gem push. This could be like a GitHub action as well. Cool, so how can others use it? So all they have to do is run bundle add admin, the name of the gem, or add it to their gem file and run bundle install. And next, they have to mount the engine. So you build the engine and they mount it. So they will mount it under the path that they want. So whenever in the parent app you go to /admin, you'll actually use the whole engine. So the routes will take over, the views will take over, the controllers, and so on. And they can see the end result. Cool. There's one more thing I haven't talked about, and it's quite important. It's the asset pipeline. So there are multiple ways of doing this, but there are like maybe two big ways. Hook into the asset pipeline. So whenever you can add your assets and adds a command, so whenever the parent app gets deployed and runs assets precompile command, that will compile your assets as well. But that's not maybe what we want, because maybe we are using ES build or something, and that requires Node.js on the deploy server, and maybe the host app doesn't have that. So we can use something else. We can precompile assets on build time. So that abstracts away the whole asset pipeline for the customer, for your user. And you can be like a superhero. Perfect. So let's see how that looks like. So inside package.json, I'm going to add a few scripts. So I have this build.js, which actually runs ES build. So it's running what's it called? JS bundling with ES build for Rails. So it's going to run ES build and take everything inside your app JavaScript directory of the engine, and will output everything to a public /admin assets, right? You can customize this path. And similarly, we're going to run for CSS, we're going to use Tailwind, and it will take one admin CSS file and publish it to admin assets /admin CSS. Everything is compiled down. So, and you have like one big script that does both of them. Coolio. And next up, this is how like the typical directory structure looks like. And what happens is you have this entry file. So this is your source admin Tailwind CSS, and then you have your source JavaScript file, right? So this is basic Rails. And what happens in development, it creates this. You have this builds directory. So everything that we had here, we actually build it inside build. So this is for production, but for development, you would actually build it inside builds, and then the asset pipeline would just pick it up and show it to the user. But now what we did, using the production scripts, we actually built them inside public admin assets. So those are the compiled assets. Those are everything, like the CSS put together, JavaScript, and so on. And how is the host app going to find those files? Because they are not like readily available. They are not mounted on a server. So we are going to use a middleware, and we are going to update the engine files. Again, when you generate an engine, you get this engine file, which is, think of it like your application RB. Whenever you have a configuration or you want to add maybe a quick initializer, you do it in application RB or in your environment file, like production and development. So this is what engine is. It's like the entry point, the Ruby entry point to your engine. And we are going to add a new middleware, rack static, and we tell it like whenever somebody goes to admin assets, actually redirect them to admin engine root and join public. So it's going to get us to that public path that we discussed. So this is how the browser has access to those compiled assets that you prepackaged. And now you'll have to do something in your application HTML for your Rails engine, and do something like if your engine is packed. So you have to figure that out. If that is packed, use the Avo assets path, so the ones that we just added here. If it's not packed, just add the simple like JavaScript include tag and add Avo and admin, and you'll be done. The asset pipeline would find them because they will be available inside the builds directory. Cool. So to recap, we talked about what is a Rails engine, generating it, sharing it on Ruby gems, push updates and versioning. We talked about the updates workflow. We talked about how to automate all of those things on GitHub Actions, and how to be an asset hero, right? To help not involve the user, the customer, in like having an asset pipeline. I have a quick community shout out. So first of all, if there are any Romanian Ruby developers watching this, go to rubyromania.ro. We're trying to set up a new community, so go check that out. And short Ruby newsletter. So my friend Lucian is doing a roundup of what's happening on Twitter about Ruby. So if you don't have time to watch like me argue with people about DSLs, or want to see what Joel Draper is doing with Flex, or Xavier Noria talking about autoloading awesomeness, go check out and sign up. So there's one more thing. I would like you to be awesome. So go and build useful things, share it with others, and most importantly, be kind, okay? I'm Adrian the Dev everywhere. Check out Avo, Short Ruby, Ruby Romania. Dziękuję. So if you have questions, please, as many as possible, because Andre is coming after me and he has a few slides that he would like to trash, like engines, and maybe he'll take them out. So as many questions as possible to cut his time short.
Hi, thank you for your talk. I have a question about other usages of engine apart from gems. Did you consider use it as a, I will give you a practice example. In our application, it was a monolith, and we were thinking about building another application inside it. Yeah, and we were discussing should be it engine because it can grow in future and we can separate it easily, or should we just namespaced inside this Rails? And what do you think? Which approach has its pros and cons? And what would you choose in this case if both applications not so big yet?
So yeah, it depends, of course. So what I would say, my general advice is like build anything to be able to scale it. Okay, scale is a very pompous word. It's a big word, but to be able to extend it or extract it if needed. So if you build anything like that, or if you build everything like that, then you'll be able to extract it easily and manage it more easily. So it all depends on what kind of functionality. So if we're talking like that marketplace that I told you about, then it makes perfect sense to have like different engines, because the buyers and the sellers are like first class citizens, so they're very important. So it's clear that the functionality is going to differ. So we need it apart. If it's something else, like I built sometimes like a while back, I built an e-commerce gateway, and we had this app, and we had like we were talking to Shopify, to Amazon, to different marketplaces. We started adding like namespaces, but then it grew too much, too big and too tough to handle. Then we extracted those things into separate engines. So we had like separate channels, separate engines for each marketplace, so Shopify, Amazon, and so on. So it all depends. You just have to talk with your team, just like you talk when you're trying to build any type of feature. What are we going to do? We use this or use that, and so on.
And also the second question, did you have experience that in both main application engine you have Webpacker?
Yeah. So we started Avo with Webpacker, There wasn't too much documentation, but if you check the code, so if anybody has like real interest into this, I can show them the code. So you can package an engine and have a Webpacker asset pipeline inside your engine. We used to do that, and you can do the same thing. You can use hook into the asset pipeline. So if you have like your app, you would like to compile all the assets when you deploy your app. But if you want to package the engine and send it to everybody else, you can use the second strategy and compile them in production and at build time. So you can definitely do that. You can add some middleware, some you hook into Webpacker. It's not easy, but you can do it.
Okay, thank you.
You're welcome. If you're curious about like ESBuild or Tailwind, you can ask me that as well, those questions.
So on your example, you have two engines, buyer and seller. So how to avoid duplication of models?
Well, that's. I was talking to Andre. You know, there are developers that like to build things, and there are developers that like to ship things. That's a job for the developers that like to build things. So you can extract things into modules and then include them inside your own models, or you can figure out like different like architectures, whatever works for your app. But if it's something like just buyers and sellers, you can have like maybe concerns somewhere and just add them here and there and so on.
Okay, but in your case, you duplicate models or you work in different way?
In my case, as with Avo, no. So actually, I don't think I have any models in Avo. Avo hooks into your app and figures out what models you have available, and then we just pick them up from I don't know where right now, from the object space, whatever. I think we're eager loading the whole app, and then we're figuring out what inherits from application record, and then we take those and do things with it.
Okay. Yeah. Thank you.
Yeah, you're welcome. Coolio. Hey, I'm available after the talk. I will be available tonight, and I'll be available on Discord. And go check out the repo. And we're really friendly. We like people playing with our code. So thank you so much for everything.